Hello, my dear students. Today in this class we will discuss NCERT exercise 3.4. So let's start question number 2. Two, one, one. Find the inverse of this matrix by using elementary transformations. Find the inverse matrix by using elementary transformation. Solution. Let A equal to 2, 1, 1, 1. We know that if we want to find inverse of A using row transformation, then we write A equal to IA and apply a sequence of row transformations on A equal to IA till I equal to BA. Then B is called inverse of A. That is A equal to 2, 1, 1, 1 is equal to I is the identity matrix of 2 by 2 order. For these elements have to be equal to 1, that is we apply R1. The three transformations are row transformations are Ri tends to interchange Rj, Ri interchange K into Ri, and Ri interchange Ri plus K into Rj. R1 tends to R1 minus 2 into R2. Then we have R1 tends to R1 minus 2 into R2. Then 2 minus 2 into 1. For these elements we apply R1 tends to R1 minus R2. Then we have 2 minus 1, 1, 1 minus 1, 0. R2, second row does not change, therefore 1, 1 is equal to R1 minus R2. 1 minus 1, 0, 0 minus 1, minus 1, 0, 1 into F. For these elements, we apply R2 tends to R2 minus R1, then we have 1, 0, 1 minus R2 tends to R2 minus R1, therefore 1 minus 1, 0, and 1 minus 1, 1. This is equal to 0 minus minus 1 minus 1, 1 minus plus 2. This is equal to 1. This is of the form I equal to BA, then B is called the inverse of A. Therefore, in A to the power minus 1 or inverse of A equal to 1 minus 1 minus 1 2. This is the required answer. If the same questions, if we apply to find inverse of A by using column transformation, then we write A equal to A into I. We know that to find A to the power minus 1 using column transformation, then write A equal to AI and apply a sequence of column transformations on A equal to AI till I equal to AB. Now we apply, that is A equal to 2 1 1 1 equal to A into I 0 1. For these elements we applying C1 tends to C1 minus C2. Then we have C1, this is called first C1, this is called C2. Therefore, C1 tends to C1 minus C2. Then we have 2 minus 1, 1, 1 minus 1, 0. C2 does not change. A equal to 1 minus 0, 1, 0 minus minus 1, minus 1, 0, 1. Next, for these elements, we are applying C2 tends to C2 minus C1. Then we have 0, 1 minus 1, 0 is equal to 1 minus 1, 0 minus minus 1 minus 1. This is equal to 2. Therefore, inverse of A equal to 1 minus 1 minus 1, 2. The answer is same. Next, we will discuss question number 5. A equal to 2174. Find the inverse of this matrix by using elementary transformations. We know that to find inverse of A by using row transformations, then we can write A equal to IA and apply a sequence of row transformations on A equal to IA till I equal to BA. I equal to BA for elementary row transformations. That is A equal to 2174. This is equal to 1001 into A. For these elements, R1 interchange R2. If we applying R1 interchange R2, then we have R1 interchange to R2. That means each element of R1 interchange with R2. Seven, 4, 2, 1 equal to 0, 1, 1, 0 into A. Next, applying R1 tends to R1 minus 3 into R2. Then we have R1 tends to R1 minus 3 R2. 7 minus 3 into 2, 6. 7 minus 6, 1. Next, R1 4. 4 minus 3 into 1, 3. 4 minus 3, 1. And second row R2 1 equal to R1 tends to R2 minus 3 into R2. 0 minus 3 into 1 minus 3, 1, 1, 0 into A. For these elements, we apply R2 tends to R2 minus 2 into R1. That means Then we have R1 applying R2 tends to R2 minus 2 into R1. Then we have R1 are same 1 1. Next 2 minus 2 into 1 0. Next 1 minus 2 into 1 minus 1 is equal to minus 3 1 1 minus 2 into minus 3 plus 6 1 plus 6 7. Next 0 minus 2 into 1 minus 2 into A. For these elements we are applying R2 tends to minus 1 into R2. Then we have 1 1 0. This is equal to 1 and minus 3 1 minus 7 2 into A. Next for these elements we apply R1 tends to R1 minus R2. Then we have R1 tends to R1 minus R2. 1 minus 0 1 1 minus 1 0. R2 does not change. R1 tends to R1 minus R2. Minus 3 minus minus 7. Minus 3 plus 7 is equal to 4. 1 minus 2 minus 1. R2 does not change. Therefore, inverse matrix of A equal to 4 minus 1 minus 7 2. This is the required answer. Next, question number 12. Six minus 3 minus 2 1. Find the inverse matrix of this matrix by using row transformations. Then we can write A equal to I into A. That is A equal to 6 minus 3 minus 2 1 equal to 1 0 0 1 into A. For these elements we applying R1 tends to R1 plus 3 into R2. Then we have 6 minus 0 minus 3 plus 3 0 minus 2 1 equal to R1 plus 3 1. This is equal to 1 and this is equal to 3 0 1. Remember, after applying 1 or 2 transformations of row or columns, if we obtained each elements of any one or columns are equal to 0, then the inverse does not exist. If all elements of any row or columns after applying any one or more transformations, then the inverse does not exist. Remember this point. Therefore, the inverse for this matrix the inverse does not exist. The inverse does not exist because for the first row all elements are 0. Therefore, the inverse does not exist. Next, we'll solve a 3 by 3 matrix. Question number 16. A equal to 1, 3, minus 2, minus 3, 0, minus 5, and 2, 5, 0. Find the inverse of this matrix by using row transformation. Then this can be written as A equal to IA. I is the identity, here I is the identity of order 3 by 3. That is, A is equal to 1, 3, minus 2, minus 3, 0, and minus 5. The third row, the elements are 2, 5, 0. Is equal to I is the arithmetic of order 3 by 3 into A. Now, for these elements have to be equal, these elements has to be equal 0. Therefore, we applying R2 tends to R2 plus 3 into R1. Then we have the first row does not change. This is equal to 0, and this equal to 0 plus 3 into 3, 9. This equal to minus 5, minus 6, minus 11, and third row are this is equal to 1, 0, 0. For this row, R1 tends to R2 tends to R2 plus 3 into R1. Then we have 0 plus 3 into 1, 3. Next, 1 plus 0 into 3, 1. This is equal to 0, 0, 0, 1. Next, for these elements have to be equal 0. Then, so we applying R3 tends to R3 minus 2 into R1. Then we have the R1 and R2 does not change. 1, 3 minus 2, 0, 9 minus 11. For this row, R3 tends to R3 plus 2 into R1. That is 2 minus 2 into 1, 2. 2 minus 2, 0. Next, 5 minus 2 into 3. 5 minus 6. Minus 1. Next, 0 minus 2 into minus 2 plus 4 equal to 1, 0, 0, 3, 1, 0. For these elements, R3, 0 minus 2 into 1, minus 2. Next, for these elements, 0 minus 2 into 0, 0. 1 minus 1 into A. Next, for these elements have to be equal 1. Therefore, we interchange R2 interchange to R2 interchange to R3. Therefore, we applying R2 interchange to R3. That means the interchange of each elements of R2 with R3. 1, 3 minus 2. Next, 0 minus 1, 4, 0, 9 minus 11 is equal to 1, 0, 0 minus 2, 0, 1, 3, 1 0 into A. Next, these elements have to be equal 1. Therefore, we multiply each elements of R2 by minus 1. Then R2 tends to minus 1 into R2, and we have 1 3 minus 2 0 minus 1 into minus 1 1 4 into minus 1 minus 4. Next 1 0 0 next 2 0 minus 1 R3 does not change this. Next, for these elements have to be equal 0. Therefore, we applying R3 tends to R3 minus 9 into R2. Then we have 1 3 minus 2. Next 0 1 minus 4. This is 0, this elements 0, 9 minus 9 into 1 9, 0 minus 11, next plus 36, this equal to 5 2 25, this equal to 25. Next 1 0 0 2 0 minus 1 and 3 R3 minus 2 into 9 into R2, 3 minus 18, 3 minus 9 into 2 18 equal to minus 15. For these elements 1 minus 9 into 0 1, 0 minus 9 into minus 1 plus 9 into A. Next, for these elements R1 tends to R1 minus 3 into R3, 3 into R2. For these elements we applying R1 tends to R1 minus 3 into R2 because these elements have to be equal 0. 1 0, next minus 2 minus 3 into minus 4, is equal to 10. Next 0 1 minus 4 0 0 25 is equal to R1 tends to 3 into R2, 1 minus 3 into 2, 1 minus 6 equal to minus 5, this equal to minus 5. For these elements 0 minus 9 into 0, that is this elements is 0. R1 minus 3 into R2. Next 0 minus plus 3 is equal to plus 3. 2 0 minus 1 and minus 15 1 9 is equal to into A. Next, for these elements have to be equal to 1. Therefore, we applying R3 tends to 1 by 25 into R3. Then we have 1 0 10 0 1 minus 4 0 0 1, 25 into 1 by 25 equal to 1 equal to minus 5 0 3 2 0 minus 1, and this is equal to 1 by 25 to minus 15 divided by 25, this is equal to minus 3 by 5, and this is equal to 1 by 25 and this equal to 9 by 25 into A. Next, for these elements, these elements have to be equal 0. Therefore, we applying R3 tends to R1 tends to R1 minus 10 into R3. Then we have 1 0 0 and R2 and R3 does not change. 0 1, this is equal to minus 4 and 0 0 1 equal to R1 tends to 10 into R3. R1 tends to R1 minus 5 minus 10 into R3 1 by 25. This is equal to 5 minus 5 minus 2 by 5 10 into R3. R1 tends to R1 is this element is minus 5 minus 10 into minus 3 by 5 minus 5 plus 6 equal to 1. This is equal to 1. Next, for these elements, R1 minus R1 0 minus 10 into 1 by 25, this is equal to minus 2 by 5 minus 2 by 5. For these elements, 3 minus 10 into 9 by 25, 5 to the 10, 3 minus 18 by 5, 15 minus 3 by 5 minus 3 by 5. And R2 is equal to minus 3 by 5, 1 by 25 and n by 25. Next, for these elements have to be equal 0. Therefore, we are applying R2 tends to R2 plus 4 into R3. Then we have 1 0 0 0 1 0 0 0 1. This is equal to 1 minus 2 by 5 minus 3 by 5 R2 2 plus minus 3 by 4 into 3 by 5 4 into 3 by 5. This is equal to 12 minus 2 by 5 minus 2 by 5. For these elements, R2 0 plus 4 into 1 by 25, 4 by 25. And for these elements, minus 1 into minus 1 plus 4, 9 to the 36 divided by 25. This is equal to 36 minus 25, 11 by 25. This is equal to 11 by 25. And the last row, minus 2 by 5, 1 by 25 and 9 by 25 into 8. Therefore, a to the power minus 1 is equal to 1 minus 2 by 5 minus 3 by 5 minus 2 by 5 4 by 25 and 11 by 25 minus 3 by 5, 1 by 25 and 9 by 25. This is the required answer. Inverse matrix of A equal to this.